Okay. Mm, Now today we'll be discussing the Unit 11, MCQs under Unit 11. That is turning effect of force. The questions are sent to the group. Okay. 2017, 10th question. In which of the following instances does a couple of forces act? When a door is opened by pushing, when a nail is unscrewed by a screwdriver, when the rope is pulled in opposite direction by two groups in a competition of pulling ropes. And the fourth one, when two persons are pushing a box in the same direction, which is kept on the floor. Now, what is this couple? What is this couple? Now, I will take a plank. Plank in a sense. Now, let me take a wood. A wood I have taken. And then from here, I'm going to give a force of 10 Newton. And here, I'm going to give a force of 10 Newton. And if they ask now, if same forces in opposite direction, equal in magnitude, act on an object, a couple is created. What is that? Equal forces, opposite in direction, and not in the same line of action. They are not collinear. They are not collinear. This is on this line, this is on this line. They are not collinear. What do you mean by collinear? 10 Newton upward, and from the same point 10 Newton downward. This is what is known as collinear. But this is not collinear. Here it's not collinear. And if it is separated by a distance of 5 meters, then the couple is force into distance between these two, distance between the line of action of both the forces. That is D. Let me take this D. So what is the force? 10 Newton into distance is 5 meters. Therefore, couple is 10 Newton meter. Remember, the units of couple equal to unit of moment. Unit of couple equal to unit of moment. What is the unit of moment? That is also Newton meter. This is Newton meter. And unit of couple is also Newton meter. Remember this. This is what is known as couple. So, you know the applications of couple when opening and closing the tap. Now, here we have the tap. Okay, in this tap, what are we doing? We are going to turn it. We are going to close it or open it. So, we are going to give a force like this direction. Outside the board, we are going to give a force outside the board, and we are going to give a force inside the board. So, if I see from the top how it looks like, this looks like this, right? If I see from the top, now this is how I apply a force now. I apply a force here and I apply a force here into the board. Here I apply a force outside the board. Here I apply a force inside the board. If I see from the top, if I see from the top, how will it looks like? This looks like this. Force in the force outside the board, force inside the board, this inside, this outside, separated by a distance d. Couple is created. Likewise, uh, turning the screw. When tightening or loosening the screw with the use of screwdriver, we are applying the couple. But yeah, therefore answer should be second one. See the first one. When a door is opened by pushing. Now this is what, right? When a door is opened by pushing. I'm going to clean this. When a door, here we have the door, here we have the door, here we have the handle, here we have the handle, and here we can see this door will be now with the use of handle, I can pull the door and I can push the door. Now this door will be rotating through this axis now. Through this axis, door will be rotating like this or it will be rotating into the board. Therefore, a moment is created from a point if I apply a force. Now let us take, I am applying a force in the outside direction, outward, outside the board. I am applying a force outside the board. Therefore, this door will rotate like this now. This door will rotate like this. This door will rotate like this. This is the axis of rotation. This is the axis of rotation. Line of axis of rotation. Therefore, a moment is created. Here, a moment is created, but moment is created. Couple is not created. Couple I have explained to you. That is, yeah. Couple is different from moment. Here, moment is created. There is no couple. First one will not be the answer. Second one will be the answer. Third one. When the rope is pulled in opposite direction by two groups in a competition of pulling ropes. Now here we have a rope. Now here we have the persons. We are pulling. Here another group is pulling. This is the surface. Okay. So if two groups pull each other, what will happen? Here tension will be created on the string. If both the groups pull each other, tension will be created in the string. Tension will be created. That tension is not something related to couple. This is not related to couple, right? That is not an application of couple. And fourth one, when two persons are pushing a box in the same direction, which is kept on the floor. Here, box is kept on the floor. Force is applied on the same direction. Here, F1 force. Here, F2 force. F1 and F2 act on the box on the same direction, on the forward direction. So the resultant of this is resultant force equal to F1 plus F2. There is no any something related to couple. No application of couple here. Therefore, answer should be second one. For this, answer number 2. Now we'll see the next question. What is the next question? Two thousand nineteen 29th question. 2019 29th question. Sorry, that is not the question. 2020 29th question, not 19 2020. Okay. The figure shows how a couple of forces is applied to rotate a wheel of 0.4 meter radius. How much is the moment of this couple? How much is the moment of this couple? So what is this? Here is yeah 5 Newton force is acting. And here another 5 Newton force is acting. So here we have the center of the circle is 0.4 meter. This is the radius, right? From the center to the out to the circumference of the circle, this is the radius. Radius is 0.4 meter. If this is 0.4 meter, this is also 0.4 meter. This is also 0.4 meter. So here they have asked how much is the moment of this couple? How much is the moment of this couple? So what is it? You know, couple is equal to force into distance. What is this distance? Distance is the distance between the two line of action. Distance between the two line of action of forces. F into distance between the two line of action of forces. Here, what is the line of action of this force? That is this. This is the line of action of this force. What is the line of action of this force? This is the line of action of this force. So what is the distance between them? Here you can see this 0.4, this 0.4, and that is 0.8. They haven't asked this couple now. They haven't asked it couple, but they have asked the force, the moment created by this, the couple created. The moment created by this couple. Okay. Either way, you can get the answer. Here, what is this? Force is 5 Newton into distance is 0.8 now. But this is not the way of saying they have asked the moment due to these forces. Now here we have the object. In this object, 5 Newton in this direction, 5 Newton in this direction. From the center, this is the axis of rotation. From this axis of rotation, 5 Newton force in this direction, 5 Newton in this direction. So they have asked the moment of this couple. So what is the moment of this couple? Moment is the, now you can see whether this is the clockwise moment or anti-clockwise moment. How are you going to say this clockwise or anti-clockwise? We are going to take this thumb, we are going to place in the axis of rotation, and you are going to see whether this clockwise or anti-clockwise. If 5 Newton is in the direction of the four fingers, here I keep the thumb in the axis of rotation, and the direction of these four fingers should show the direction of four fingers is in the direction of force given, then that is clockwise. This is clockwise. So this a clockwise moment is created by this 5 Newton. By this 5 Newton, a clockwise moment created. Now here, now we'll see for these forces whether this force will create a clockwise moment or anti-clockwise moment. Here I take the thumb, I keep it in the axis of rotation. I'm going to take these four fingers. I'm going to go like this. And you can see these four fingers is in this direction. Yeah, four fingers are in this direction. In the same direction, this force is acting. Yeah, four fingers show this direction. This 5 Newton force is also in the same direction. Therefore, I can see this also in the clockwise moment. This also create a clockwise moment. So both are clockwise moment. Then I can edit, right? So from what is this moment? Moment is force into perpendicular distance from the line of action to the axis of rotation. Product of or multiplication of force into the distance between the axis of rotation to the line of action of the force. Therefore, Moment due to this is 5 Newton into 0.4 meters. That is one. And the moment due to this is also 5 Newton into zero point 0.4 meters. Here, the 5 Newton force, the distance between the axis of rotation to the line of action of this force is 0.4 meter. Therefore, 5 into 0.4. 5 Newton into 0.4 meters. Therefore, because these two are in the same moment, this also clockwise, this also clockwise, this also clockwise, this also clockwise, I can add both the clockwise moments. So 5 Newton into 0.4, this one, plus 5 Newton into 0.4. Therefore, if I take this 5 as common, 2 into 5 Newton into 0.4, that is equal to 5 into 2 into 0.4 is 0.8 Newton meter. So what's the answer? Answer number 2. This is not the way of doing. They haven't asked the couple. They have asked the moment created by the couple, the moment created by the forces. So this clockwise, this is clockwise. I can add both the clockwise moments. If I will get the final answer 5 into 0.8 Newton meter. That's it. So answer 2. This is 2020 29th question, answer 2. Now let's see like this. Now let us take the 5 Newton force is acting like this. 5 Newton force is acting like this. Now this is the axis of rotation. We are going to keep the thumb here. We are going to move the fingers in the clockwise direction. This force is in the direction of clockwise direction. Therefore, this is a clockwise moment. But here, if you see, when you move the hands in the clockwise direction, you can see that these 4 fingers are in this direction. These 4 fingers are in this direction, but the 5 Newton is in the opposite direction. The 4 fingers show this direction, 5 Newton force show the opposite direction. Therefore, this creates an anti-clockwise moment. Anti-clockwise moment. So this is clockwise, this is anti-clockwise. If they ask the moment due to couple, now this is not a couple, but the moment due to forces, what are you going to do? Here we have the clockwise moment, that is 5 Newton into 0.4. But here, because this is in opposite direction, not the same clockwise. This is clockwise, this is anti-clockwise. If they are in the same, if the same clockwise moment is created, you can add them. If same anti-clockwise moment, you can add them. If clockwise and anti-clockwise are in opposite direction, then if clockwise and anti-clockwise are acting on the body, you should subtract them. Minus 5 Newton into 0.4 meter. For 5 into 0.4 is 0.22 Newton meter minus 2 Newton meter. Answer is 0. Moment created by the forces 5 Newton and the 5 Newton on this object is 0. Moment is 0. I have just said you to give some extra points. If you need this point, write it down. I'm going to clean this. is the next question? 2000, 2021, 29th question. 2021, 29th question. The next one is 2022, 18th question. Let's keep it apart. I will do this. 2021, the diagram shows 2021, 29th question. Diagram shows a cross section of a cylindrical concrete ring kept on a flight of steps. Indicate as A, B, C, D, indicated as A, B, C, D are 4 points at which forces can be applied by a man to roll it to the upper level. What is the point at which force can be applied to the cylinder in a suitable direction to roll it up with the lowest force? This is going to happen. Now these are step. These are step. Now this is like this is a concrete ring. Concrete ring. You have seen this. Now to drainage, they will put this type of a structure, right? Concrete ring, right? This is what it is. So what are they going to do? They're going to take this concrete ring up the step. They're going to take this concrete ring here. They're going to take this from the here to here. They're going to take this here. Okay. Now they have given how many points? 4 points are given. This is point A. This is point B. This is point C. And this is point D. Now how can I pull this up? I can tie a string, like I can tie at this location. I can tie a string at this location. tie a string at this location, or tie a string at this location, and then I'm going to take the string. Now let us take. I'm going to, yeah, I have tied a string, and then here are forces. Okay, they are going to pull this string. So this concrete string is going to move up. This is what's going to happen. So in the question they are asking, what is the point at which force can be applied to the cylinder in a suitable direction to roll it up with the lowest force? You see, this is the key point. Lowest force. What is this lowest force? Now, this string is going to move up like this, right? Now, this is the point. This ring is going to roll up like this, and then it's going to come here. This string is going to roll from this rotation. This is going to be the axis of rotation. Now, here see. Now, here we have the rotation. Here we have the ring. The ring is going to move up like this. No. Now they are going to pull. No. The string, the ring is going to move up like this, and then it's going to reach here. They are going to move up like this and going to reach here. Therefore, from this point only, the ring will be rotating. From this point only, the ring will be rotating like this and reach the steps here. It will reach here. This is what going to happen. Okay, so you can see the axis of this is going to be the axis of rotation. This is going to be axis of rotation. So from the axis of rotation, I'm going to give a force here. So if I apply a force now with the string, a force is going to be applied like this, right? Here, by the string, a force is going to be applied like this. Therefore, this is the line of action of the force, and this is the axis of rotation. And then from this axis of rotation, a clockwise moment will be created. From this axis of rotation, a clockwise moment will be created. Clockwise moment will be created. So they have asked, what is the lowest force in which point that I should tie the string? In A, B, or C, or D, in which points I should tie the string so that I can apply minimum force to lift the string, to lift the ring up the step, to lift the ring up the step. What should be the minimum force or lowest force that I should apply? You know, the moment is equal to force into distance. If I need to create a minimum force, if I need to create a minimum force, if I need to create a minimum force, then what should be the distance from the axis of rotation? The distance from the axis of rotation should be maximum. If this is minimum, that should be maximum. So what is the maximum distance from the axis of rotation? That is this, right? D1, D2, and clean this part. Wait a bit, it's as a